Flow Sciences was the first company to develop and commercialize the vented balance safety enclosure for personnel protection and balance stability. The engineering controls that we put into the design ensure a vibration-free environment, maintaining 5- and 6-place micro-balance stability as well as ultra-micro-balance stability, and you'll see that in the following video. Test 1. A granite block was laid on the center of the concrete tile floor in the laboratory. The sensor was placed on top. This was to isolate the sensor as much as possible from any vibrations and get a baseline or reading. Test 2. The sensor was placed and centered on top of an iPhone set to vibrate. This was only to get a real-world comparison between a vibration most people are familiar with and the G-forces created. Test 3. The fan was set to maintain a standard face velocity. The sensor was placed on top of the fan unit. This was to determine what vibrations are created by and present at the fan unit on top of the enclosure under normal operating conditions. Test 4. With the fan still set at a standard operating face velocity, the sensor was placed beside the enclosure, centered on the benchtop work surface. This was to determine what vibrations travel through the enclosure from the fan unit onto the actual benchtop work surface. Test 5. The fan still operating at a standard velocity. The sensor was placed inside the enclosure, centered on the phenolic work surface. This was to determine what vibrations travel through the enclosure from the fan unit directly onto the work surface. Test 6. The fan was turned off. The sensor was again placed centered on top of the fan unit. A half-inch diameter, 8.35 gram steel ball was dropped from a height of 2 feet onto the top of the fan unit. This was to create a vibration with a peak force greater than 0.5 G-force. Test 7. With the fan still turned off, the sensor was placed inside the enclosure, centered on the phenolic work surface. The same steel ball was again dropped from a height of 2 feet onto the top of the fan unit. This was to see if any vibrations would travel to the enclosure's work surface. Test 8. A Janssen 300 count capsule machine at approximately 50% power was used for an example of a machine that creates vibration to determine a baseline reading for actual G-force. We then moved the sensor into the enclosure to determine if the vibration from the machine would transfer onto the phenolic work surface. In conclusion, what you just saw is that there are no measurable vibrations detected on the phenolic work surface from an adjacent piece of equipment on the same bench that was vibrating, nor were there any vibrations detected from the fan unit down to the work surface. Therefore, Flow Sciences has designed and engineered a vibration-free environment for any process in your lab. For more information on the Flow Sciences vented balance safety enclosure and our custom capabilities, please visit www.flowsciences.com or email us at information@flowsciences.com, or even give us a call at 1-800-849-3429.